Soy Juan Alberto Alcántara y a nombre del Instituto Politécnico Nacional y del CIIEMAD, en el marco de los festejos del 84 aniversario del IPN, es un gusto darle la más cordial bienvenida a esta sesión, donde escucharemos la conferencia Seawater Incursion in a Coastal Area of South India, an Integrated Approach and Engineered Solution for Mitigation. Incursión de agua de mar en una zona costera del sur de la India, un enfoque integrado y una solución ingenieril para la mitigación de esta. Actividad que forma parte del programa de la Cátedra Patrimonial en Medio Ambiente Héctor Mayagoitia Domínguez en su versión 2020. Es la quinta edición. Presento a nuestro ponente del día de hoy, que nos hace el favor de acompañarnos. Me da mucho gusto darle la bienvenida al profesor del Departamento de Geología de la Universidad de Anna de la India, el doctor Subramani. Cabe mencionar que en la India son las 9 de la noche. Entonces es muy importante esta parte. El doctor nos hace favor de estar con nosotros hoy en la noche, allá. Sea usted bienvenido y muchas gracias por aceptar la invitación, doctor. You are welcome and thank you very much for accepting the invitation.
Yes, thank you, Professor.
La dinámica de la sesión será la siguiente. El ponente tendrá 45 minutos para su exposición y posteriormente tendremos una sesión de preguntas y respuestas de 15 minutos. The dynamics of the session will be as follows. The speaker will have 45 minutes for his presentation. And later, we will have a question and answer session of 50 minutes. Les recordamos que pueden hacer preguntas por el chat de YouTube y que nos indiquen su nombre, la institución a la que pertenece. Aprovecho también para solicitarles que se suscriban a nuestro canal de YouTube. Y bueno, antes de pasarle el micrófono a nuestro ponente, me permito compartirles un resumen de su semblanza. El doctor es profesor del Departamento de Geología de la Universidad de Anna de la India desde 2015. También ha sido jefe superintendente de exámenes de posgrado. El doctor tiene una maestría en Ingeniería Ambiental, otra en Geología Aplicada. Su grado de doctor lo realizó en Identificación de Procesos Hidrogeoquímicos. Y, por otro lado, su área de especialización es Ingeniería en Geología, Hidrogeología, Ingeniería de Aguas Subterráneas, Tecnología Geoespacial con Teledetección e Ingeniería Ambiental. El doctor Subramani ha guiado a 12 becarios de doctorado y más de 25 estudiantes de maestría. Además de que cuenta en su haber con 83 artículos de investigación en revistas internacionales. Y bueno, por otro lado, también le doy una cordial bienvenida al doctor Jonathan, profesor del CIIEMAD, para apoyarnos en la traducción de las preguntas y respuestas. Doctor, puede iniciar la presentación. Doctor, you can start with the presentation, please.
Yeah, I'll start now.
Thank you. Okay.
Yeah.
Yep.
So good morning to all of you. I'm happy to talk on this particular topic, seawater intrusion. So I'll here this topic is very important in the present scenario. So in the coastal areas, so the seawater intrusion is very common. So it is disturbing the environment. So it is polluting the groundwater, and also it is polluting the surface water. So that is why I'm planning to give a talk on this particular topic. So at the outset, I would like to thank the organizers, particularly my friend Professor Jonathan, for inviting me. It's COVID pandemic. So this seawater intrusion in the coastal area of South India. So we have used many proxies, many techniques to identify the seawater intrusion areas. Then finally, we have given a solution it's a kind of engineering solution to minimize or to mitigate this environmental issue. So actually, this work is one more person, Mr. P. Sadish Kumar, has also involved in this particular work. So here, this is the area of study. So this India, this study area is located in the extreme southern part of India, and this state is known as Tamil Nadu state. And again, in the Tamil Nadu state, the study area is located in the southern part. So this is the location. This is Tamil Nadu state, and this is the deltaic area. So here in Tamil Nadu, there are many river basins. So in the center of the state, Tamil Nadu, there is a huge river system. It's called River Kaveri. And this basin, river basin, is located in the southern part of Tamil Nadu. And I have chosen this deltaic area for detailed investigation. And this river basin is known as Tamarabarni River Basin. So it originates in the hilly areas. It is known as Western Ghats. And it is this river. So the main stream of the river is considered to be a perennial river. So throughout the year, we can expect water flow in this particular river. And finally, this river confluences with Bay of Bengal. So here we have sea, Bay of Bengal. Then coming to the problem, so here you can see the photographs and the satellite image. So initially I have taken this satellite image for detailed study, and this is the IRS-1D. Name of the satellite is Indian Remote Sensing Satellite 1D. And the name of the sensor is LIS-3, Linear Imaging Self-Scanning Sensor 3, with the resolution of 23.5 meters. Spatial resolution of this satellite data is 23.5 meters. So here is a false color composite image, and the red color indicates vegetation. So this red color indicates vegetation. So all along the river course, Tamarabarni river course, we can see thick vegetation. And here, this is actually a sand dune, very close to the coastal area. So we can see the sand dune. So it is green in color because I told you it's a false color composite. And this area, we can see a lot of salt pan activities. So I have here you can see the photographs, and this is the barrage or weir constructed across the Tamarabarni river. This is the last weir. So there are so many weirs constructed in the upstream, in the hilly areas. And here, this is the last weir or barrage. Then, so there is a bridge here. So it's constructed by Highways Department. And during the construction of this bridge, so they have investigated the river profile, and they have gone for pile foundation. So we collected a lot of data like river discharge, they have estimated. So we collected data from the Tamil Nadu Highways Department because they have constructed bridge across the Tamarabarni river in the deltaic area. And here, this is, I told you, this is a dune sand, is a river, is a wind deposit. You can see red color sand dune. So it is in the southern part of the study area. And here you can see, this is here, there are a lot of salt pan activities are going on. So you can see here. So they are producing salt. So sometimes they are using seawater directly, and sometimes they are using saline groundwater for producing salt. So here in this picture, you can see there is a pumping station. So this pumping station is located here. So there are so many industries located in this area. And of course, they are processing the beach sand. So in this part of the coast, the sand is having a lot of heavy minerals. And this area, this coastal area is known for heavy minerals. There are so many industries are processing the heavy minerals, and they are extracting titanium from ilmenite and rutile, and thorium ore. Monazite is also enriched in beach sand, and we have garnet, we have magnetite. So many heavy minerals are available in the beach area. So that is why there are so many industries are located in this region. They are simply bringing the sand from the coastal area, and they are processing the sand, and they are separating valuable minerals and metals. And so for their industrial purpose, they are directly taking this river water for their industrial users. The industry people, they are directly taking the water, surface water, river water for their industrial applications. So here what happens, so particularly during summer season and also during high tide period, so this seawater is entering into the river channels. So here you can see, so this seawater is entering into the river channels and it is contaminating the water, river water. So this effect is noticed up to the place called Aral. It is about 7 kilometers inside. So because of this seawater incursion, so the people are not able to use the water for their industrial applications. And also farmers are also struggling a lot. They are not able to use the river water as well as the groundwater for their agricultural activities. So what they have done is, they have done some temporary solution to minimize this entry of seawater into the distributaries of Tamarbarni river in the deltaic region. So they constructed these type of temporary earthen bunds. So this is a temporary earthen bund constructed across the river channels by the farmers, by the local people and the industrial people. So otherwise they cannot use this river water directly for their industrial applications and agricultural activities. So that is why they created this type of temporary earthen bunds across the river channels. Then another important issue here is, so they are not bringing any sand or any material from outside to construct this bund. So simply they are dredging the sand available in the river course and they are making these kind of bunds. Temporary, I can call it as a temporary earthen bund, because I told you this is a perennial river. Throughout the year you can expect flow, but during heavy rainy season or flood season, so all these bunds will be washed away. So this entire sand material will be pushed into sea. So knowingly or unknowingly, they are deepening the river channels. So they are deepening the river channels. So if the river channels are deepened, then more amount of seawater can enter into the river system. So this mistake they are doing in the coastal area. Then here you can see, so the river channels are there. Then once the bund is broken, once the bund is, say the sand material is pushed into sea, so they are again making the bund. So it is a continuous phenomena. So these bunds are completely washed away by the river water. And so to understand the tidal fluctuation, so we have fixed a scale. Actually this side is towards sea and here this side is towards sea and this side is upstream river side. So we fixed a scale here to measure or to understand the tidal fluctuation at this particular area. Then here we can see the another important issues. So in this photograph, you can see the good agricultural fields. There are a lot of trees and some crops are there. And what these poor farmers are doing is they are simply converting the fertile agricultural land into salt pans. So in some of the areas, fertile agricultural lands are converted into salt pans. So why? Because so if they do agricultural activity, they are getting less revenue, less money. So to get more money, to earn more money, they are converting the agricultural field into salt pans. So here you can see the salt pans, and so because of this, so the fertile land is affected. So this photograph shows salt affected agricultural land. So it is not quite easy to go for reclamation of the contaminated areas. So soil is completely polluted. So not only river water is polluted, say not only the groundwater is polluted, and also land is also polluted. Soil is also polluted. So this is the salt affected land in this area. And here you can see this gentleman. So he is measuring. So he is measuring the say density of the water. Why? Because they are not simply using the seawater for producing salt. They are not taking the seawater directly for producing salt. So what they pipe and they are taking the saline groundwater. So when you go down, So obviously, so the density of the water is more and the groundwater is more saline. So they are able to produce more salt. So that is why, so people are using saline groundwater for producing salt. So because of, so pumping of groundwater from the aquifers, so seawater incursion or seawater intrusion is also taking place in the aquifer system. So it is not only spoiling the surface water or river water, and also it is contaminating the aquifer system. So keeping all these things in our mind, so we have chosen this area for detailed investigation. So initially, we have prepared various thematic maps using satellite images and using geographical information system. And these are all some of the maps we have prepared from satellite images and also based on the already existing maps. So this is the drainage map of the area. So here you can see this is the main stream, Tamarabani River, and you can see the distributaries. And these are all the major water bodies, tanks in this study area. And you can see the major settlements or villages in this area. And this shows the watersheds or sub-basins in this area. So this is the major basin. And within the basin, you can see sub-basins and watersheds. And these are all the name of the watersheds. And here in this map, this is the land use map of the study area. We can see various land use categories. Say, for example, this is the salt pan. Salt pan is here. Swampy area is here. And you can see in this area, you can find dry crops. So, and here this map is actually geomorphological map. And also I have marked the lineaments. These are all the lineaments. So with the help of the satellite image, I have prepared this lineament map. So we have identified the major lineaments. And you can see the swampy area, so beach terraces, so beach ridges. So many geomorphological landforms are identified, and you can see in this map. And sand dunes. So these are all the stabilized sand dunes, and you can find the sand dune here. It's a wind deposit. So this map gives various landforms in this area. Then this is the soil map of the area. We can see different types of soil, and some places we can find clay soil. So some places you can find say more loamy soil. And this is the slope map of the area. And in the coastal area, slope is almost flat. So here this pink color indicates the almost leveled surface. Then very gentle slope, you can see this yellow color indicates very gentle slope. Then you can see the gentle slope. So slope is also another important factor here. So because the terrain is almost flat or the gentle slope, so the seawater intrusion is taking place. So we have to consider this slope also for detailed investigation. Then we have collected secondary data from various government and private departments. And I have already told you, so there is a bridge constructed across the Tamarabani River, so in the deltaic area. So at the time of construction of this bridge, so they have done a lot of estimation. For example, they have calculated the discharge. So how much quantity of the water is passing through this area. Then they have gone for pile foundation. So they studied the subsurface also. So what kind of strata is available below the riverbed. So many details we have collected from the Tamil Nadu Highways Department. Then, so I told you this is the last barrage constructed across the river. So from this department, so actually it comes under Tamil Nadu Public Works Department. So from this government agency, so we collected the surplus details. So how much quantity of the water is passing through this particular barrage. And here we can find the canals also. There are canals available in this barrage in the right side as well as in the left hand side. And so port is also there in this area. So it's Tuticorin port. So from the port, so we have collected data. We have collected the tidal fluctuation data. So high tide and low tide details we have collected from the Tuticorin port trust. Then after collecting the secondary data, so we have gone for land use land cover change analysis. So this is the land use land cover change detection analysis. So we have taken the satellite image of 1998, and this land use land cover map was prepared. So we have taken few major land use categories. and we have identified all the categories with the help of the satellite images. So here you can see the cropland, fallow land, land with scrub, land without scrub, marshy areas, then plantation, then salt pans. So this is an important thing, salt pan activities. Then this is this land use land cover map of 2008. Then we prepared the land use land cover map of 2018. So finally, so we made a tabular column here. So in this we can see the variation. So change reduction we can find here. So particularly if you see the salt pan, so salt pan is actually increased. So about 5.79 kilometer area it is increased, and you can see the plus symbol indicates increase and minus symbol indicates decrease. So some of the land use categories are decreased and some of the land use categories are increased. And of course, in the case of water bodies, in the case of rivers or canals, there is not much variation. And some of the lands with scrub and without scrubs were converted. Okay, this is the overall scenario, land use land cover change scenario in this area over the period of say 20 years. Then, so we collected water samples, groundwater samples and surface water samples for understanding the aptness or suitability for consumption purpose. So in this area, these are all the sampling points, locations, and this red color dot indicates groundwater sampling locations, and this pink color dot indicates surface water samples. So we have collected 40 groundwater samples and 21 surface water samples during winter season as well as the summer season. So to understand the say seasonal variation, to understand the spatial variation, we have collected samples during winter and summer. So here you can see the summary of the water quality analysis. So you can see the analytical results. So we have presented the maximum, minimum and average values for winter season as well as for the summer season. So this is for groundwater samples. So I have mentioned 40 groundwater samples we have collected, and this is the summary. So here you can see the TDS value. So TDS values maximum, it is about 36,800 milligram per liter, and average is 5,134 milligram per liter. So we all know that as per the WHO, World Health Organization standard, so if TDS is more than 1,500 milligram per liter, so the water cannot be used for drinking applications. So here the minimum value is of course less if you go in the upstream side. So the minimum value is 100, so the maximum value is 36,800. So similarly, in the case of summer season, it is higher actually. So the maximum value is 40,650 and the average is 5,652. So that is why people are not able to drink the water in various villages or locations. And you can see the minimum and maximum values of the other parameters. So particularly for seawater intrusion, so we must concentrate on sodium, we must concentrate on chloride, we must concentrate on bromide also. And this is for surface water samples. So we have collected samples from the river channels, distributaries of a river, and here also you can see the TDS. So TDS is very high in the surface water samples also. Similarly, you can see the chloride. So similarly, you can see chloride is high, bromide is also high at many locations. Then, so initially we used this geochemical signatures as a proxy to identify the seawater intrusion areas. So here, based on the TDS, this is the spatial variation map. So it shows that, so here I made various categories, 7 categories. So in this, so if you see this red color, so here the TDS value is more than 30,000 milligram per liter. So here this pink color indicates 20,000 to 30,000 milligram per liter. So as I mentioned, so if the value is more than 1,500 milligram per liter, so you should not supposed to use the water for drinking. So this entire area is not suitable for drinking. Even this yellow, green, blue, pink, and red. So this entire area is not suitable for drinking as per WHO standard. Similarly, this is for winter season. So sorry, this is winter and this is for summer season. And this is the scenario based on sodium concentration. And we made two categories. If the sodium is less than 200 milligram per liter, it is suitable for drinking. If it is more than 200, we will not use. And you can see this area is not suitable for drinking. Similarly, this area is not suitable for drinking. Of course, we have prepared spatial variation maps for all the major ions. And here I am presenting only sodium, chloride, and TDS. So here you can see we made three categories. So based on say sodium chloride concentration. So if the chloride concentration is more than 600 milligram per liter, we should not supposed to use the water for consumption. So here this entire area is not suitable, and here this area is not suitable. Then this is the Piper trilinear diagram to understand the geochemical phases. So normally we will prepare these type of diagrams. So here there are 6 fields in the diamond-shaped box, and this triangle is for cations, and this triangle is for anion, and this is in this diamond box we can see 6 categories. And here this diagram is for groundwater samples, and this diagram is for surface water samples. So here you can see many samples are falling in the first category, sodium chloride. So samples are representing sodium chloride type of water, and so many samples are falling in the field of mixed CaMgCl type. So these two are the major geochemical types of groundwater. One is sodium chloride, another one is mixed CaMgCl type. So here in this surface water samples, so most of the samples are representing sodium chloride type. So this indicates seawater intrusion is taking place in the deltoid area. So this is another important clue or evidence. So based on that, we can identify the seawater intrusion. And to know the rock water interaction, so we have prepared this Gibbs plot. So in the Gibbs plot, so many samples are representing rock water interaction dominance, and some samples are representing the evaporation dominance. So here you can see, so rock water interaction is also playing an important role in this area. So it is taking place. Subsurface geochemical process is also important thing to understand the evolution of groundwater in this area. Then, so finally, so we have prepared this chloride by bromide ratio, and this diagram, in this diagram we can see we have plotted the points. So in the x-axis I have taken chloride, and in the y-axis I have taken chloride bromide ratio, and this is the small line, and some of the dots, these dots are indicating salt pans, and here you can see the agricultural activities. So this is an important indicator, and here I have taken both the monsoon season samples, the summer season as well as the winter season. And finally, so we have tested the water for irrigation applications, irrigation practice also. So we have prepared Wilcox diagrams, we have prepared USSL diagrams to know the suitability of water for agricultural activities. So here you can see many samples are falling in this field. So you can see this is in the x-axis you can see the salinity hazard, and in y-axis you can see the sodium hazard or alkali hazard. So there are 4 categories based on the salinity hazard: C1, C2, C3, and C4. So based on the sodium hazard, we can see S1, S2, S3, S4. So many samples are falling in these fields: C4, S3, and C4, S2. So these samples, we should not supposed to use these waters for irrigating soil. So what will happen if you continuously use this water for irrigation? Then this will reduce the porosity because the sodium content is more. So salinity is more, sodium content is also more. Then this water will reduce the porosity of the soil. So obviously, then the plant roots cannot freely penetrate into the soil. So soil will become very hard. So finally, it will affect the crop yield. So we cannot get more yield. So normally, what the people will do is they will apply gypsum sometimes they will apply gypsum. So gypsum can give some kind of remedy. And here also you can see it's the surface water samples, and some samples are representing this C4S3 field. So this water should not be used continuously for particularly the soils having poor internal drainage. So it will affect the porosity as well as the permeability of the soil. Then this is the unsuitable areas identified based on the sodium adsorption ratio, and this is for groundwater samples. And here we made 4 categories, and the last 2 categories if you see, and if the sodium adsorption ratio is greater than 18, so normally this water is not suitable for irrigation purpose. So here you can see 48 square kilometer and 37 square kilometer. This area is not suitable for irrigation. And similarly for summer, you can see 80 square kilometers is more when compared with the winter. So more area is affected. So 80 kilometer and 80 kilometer square and 30 kilometer square. This area is not suitable for irrigation purpose. And here this is based on the say percent sodium. So here you can see the map. There are 5 categories. So normally in the Wilcox diagram you can see all the 5 categories. So if it is greater than 60%, so the water is not suitable. Generally it is not suitable for irrigation purpose. So here you can see this area is not suitable for irrigation purpose. So during summer you can see more area is affected. So water in this groundwater in this area should not be used for irrigation purpose. So based on the percent sodium. So after considering all the geochemical parameters, so we have demarcated the seawater intrusion zones. So this is based on the geochemical signatures. So here you can see the sampling sites, and this entire area is affected. So this zone, we have demarcated the zone. So this area is affected. So based on the well samples, based on the surface water samples, so we have identified this area. Okay, I have already told you. So the surface water is also affected. So that is why, so the pumping station here at this site, so they are not able to directly use the surface water or river water for industrial applications. If the water is not suitable for industry, then the water cannot be used for drinking as well as for irrigation purpose. And we have done some aquifer vulnerability index modeling, and we have used this GALDIT model, and we have collected primary data. Here this is the flow chart, simple flow chart explaining about this model. So here you can see the data. Initially we have collected secondary data, then we have collected primary data, and we have established, we got these parameters. So we need 6 parameters for this particular model. So finally, so we have assigned ranks and weightages. So based on the ranks and weightages assigned, so we have used, of course, GAS to integrate the maps, to integrate or superimpose the maps and thematic layers. We have used GIS, and finally, so we have prepared aquifer vulnerability maps of winter as well as for summer season. And these are all the 6 parameters considered in this model. And groundwater occurrence, G in the GALDIT, G is groundwater occurrence, A is hydraulic conductivity of the aquifer, and L is depth of the subsurface water level, groundwater level, and distance from the shore is indicated by D. I is the impact of the current marine intrusion status. Then T is nothing but the aquifer thickness. So using this formula, so here we can, as I mentioned, we have to assign proper weights and ranks. Then finally, so we have prepared the aquifer vulnerability index maps. And here, this is the first parameter, this subsurface groundwater levels. And using various colors, so we have indicated the depth of groundwater level in this area during winter as well as during the summer seasons. And this is the seawater impact status So during winter season as well as during the summer season. And this here you can see the hydraulic conductivity. So hydraulic conductivity is more in the sand formation. So here you see hydraulic conductivity is more here, and hydraulic conductivity is less here. And here you can find hard rock areas. Hard rock you can find in this area. And this is the map showing the distance from the shoreline. So 500 to 1000 meters. Okay, so above 1000-meter distance is indicated using this green color. So this is an important parameter used in the Galdit index model. And finally, so we have made into 3 categories. So the first one is low vulnerability areas, moderate vulnerability areas, and high vulnerable areas. So here you can see during winter season, so 225 square kilometer area is coming under low vulnerability, and this 126 square kilometer area is coming under moderate vulnerability, and this indicates the high vulnerable area. So similarly for summer season, so it is high when compared with the winter season. So this is the output we got, final output we got from this particular model. So initially we have done, so based on the geochemical signatures, so we have identified demarcated the seawater intruded areas, and we have done this Galdit model to identify the vulnerable areas. So this is the final map. So this is for winter season, and this is for summer season. So here 3 categories you can see: low, moderate, and high. This is highly vulnerable for seawater intrusion, and this is the moderate vulnerable, and this is low vulnerable zone. And we have done resistivity survey also. So next step is, so we have carried out electrical resistivity survey in this area, vertical electrical sounding. These are all the locations or the villages chosen for vertical electrical sounding. So we have used simply the Venner method for this purpose. And finally, from the data, so we have, this is the resistivity of the first layer, resistivity of the second layer, and resistivity values of the third layer. So here you can see the values, and we have prepared the isoline maps as well as the zonation maps. So isoline maps are nothing but the contour maps connecting the points having the same values, and choroblick map is nothing but the zonation map. So we made into different zones for easy understanding, for easy visualization. And here this is the resistivity of the third layer. Okay, then so these maps are showing the thickness of the layers, and here you can see the thickness of first layer and the thickness of the second layer. Then finally we have compared all the methods. So this is based on the geochemical signatures, and this is based on Galdit modeling, and finally this is based on vertical electrical sounding. So almost you can see the match. So based on the geochemical signature, so this much area is affected, and here also you can see this high vulnerable, and here also the electrical resistivity survey is also showing this almost similar kind of result we are getting. Then finally, so we have to give solution to the people. So in most of the scientists the geologists are approaching the problem, and we are identifying the problem, we are collecting a lot of data, we are publishing a lot of papers, but we are not giving the solution to the public. So here we have given engineering solution to the people to minimize. So we cannot stop 100%. So to minimize the seawater intrusion, we have given the solution. Then by keeping all the data, so finally we have identified a site to construct a weir across the Tamarbarni river to minimize the intrusion. So this is the place called Mukani. So we have identified this site for constructing the weir. It's a kind of solid weir. So we have done the design parameters, And here you can see at that side, this is the profile of the river. So we got the river profile. And of course, in large scale, here you see the scale is 1:1900. It's a large scale map. Then this is the subsurface detail. So on the top we have sandy soil, and below that we have clay soil. So accordingly we have to go for foundation. Then this is about the river discharge. So we got details from the Tamil Nadu Highways Department, and also we collected data from the Public Works Department. So we have considered all these parameters. So wetted perimeter, so depth, river bed, so river bed level, everything we have considered for design, weir design. And here you can see the velocity and discharge calculation. So as per our calculation, so we got the maximum discharge at the proposed site as 1873 meter cube per second. So this much quantity of water is passing over the area. So this as per our calculation. And at the time of the construction of the bridge by the Highways Department, so they estimated as 1450. So we estimated as 1870, and they estimated as 1450 meter cube per second. Then these are all the parameters for weir design. Here you can see the name of the river, then location, nature of the bed, and so we assumed the maximum flood discharge as 2000 meter cube per second. And here the maximum flood level is 6 meters with respect to mean sea level, and the bed level is 1.2 meters above the mean sea level, and the maximum tidal rise we have measured by putting a scale, it is about 1.5 meters with respect to MSL. So here the width of the river at the proposed site is 380 meters. And finally, we decided to go for to construct OGI type of surplus weir or overflow weir, and we used Kosla's theory and we used Manning's formula for this design for establishing the design parameters, and linear waterway. So we used two methods and we got this value. So linear waterway is about 350 meters we have taken. And the crest level of the weir, so we decided to construct 1 meter height solid weir across the river channel. So if the height of the weir is more, then the afflux rise will be more in the upstream side. So it will submerge the water and it will act as a barrier for flood. So during flood season, so a lot of areas will be submerged or it will be disturbed. So that is why we decided to go for 1 meter height solid weir in the deltaic area. So if you see the crest level of the weir, it is about 2.2 meters. So bed level is 1.2 and the height of the weir is 1 meter. So crest level of the weir is 2.2 meters above the mean sea level. And score depth we have calculated using the standard formula. So this is the score level we got. And here you can see the length of the backwater. So if you construct weir or if you obstruct, if you put some hydraulic structure across the running water, and the backwater will be there in the upstream side. So it is about 1500 meters. And water cushion, so length of the water cushion should be 2.4 meters. Then guide banks. So we have to flow the guide towards the hydraulic structure. So height of the guide banks is 6.1 meter. And so here you can see the length of the guide bank in the upstream side is 385 meters. And in the downstream side also guide banks should be put. And so up to approximately 90 meters we have to put the guide banks in the downstream side from the weir. And this is the key plan of the abutment and cutoff walls. And this is the sectional view of the abutment and return walls. And here we decided to go for two cutoff walls or sheet piles. So one is in the upstream side, another one is in the downstream side. So normally we will not provide this cutoff wall. So this cutoff wall, this downstream cutoff wall is mainly to avoid the piping failure of the hydraulic structure. So if you don't put this cutoff wall, so what will happen? This water running below this hydraulic structure or weir will remove the sand particles, and piping failure will occur. So to avoid piping failure of the structure, so we have to create this, we have to put this downstream sheet pile. And this upstream sheet pile is to minimize the subsoil hydraulic gradient. So if you don't put this, say what will happen? So if you put this structure, so it will reduce the pressure. So to reduce the upliftment pressure, so normally they will provide this cutoff wall. So what happens, this is the initial subsoil hydraulic gradient and this is the ponding. So here the water storage will be there. And if you put the cutoff wall here in the upstream side, this is the weir and this side is upstream side and this is the downstream side of the weir. And if you introduce this cutoff wall, so suddenly the subsurface hydraulic gradient, that means the upliftment pressure or the pore water pressure is reduced. And obviously, if you put downstream cutoff wall, it will increase the pore water pressure. But to avoid the piping failure of the structure, we need to provide this downstream cutoff wall. So this is the depth. Up to 6 meter depth we have to provide here. Up to 2.5 meters depth we have to provide in the upstream side. And finally, we have done the stability check. So if the river is carrying water up to the crest level of the weir, whether this structure will be stable or not, because we are going to construct the weir over the sandy bed. So if the structure is not stable, if the river is carrying huge water during flood season, so the structure should withstand. It should be stable. So that is why we have done the stability check. So if the river is carrying water up to this level, whether the structure will be stable or not, and if the river is carrying the maximum amount of water during flood season, whether this structure will be stable or not. So this is the stability check when the weir is discharging full quantity of water during the flood season. And finally, this is the plan view of the weir. Then this is the sectional view of the weir. So this solution we have given. Say before coming to the conclusion part, so I will tell you the importance of this work. So we have, after completing this work, so we have submitted the report to the government. So otherwise, so there is no meaning in conducting study and publishing the data in the form of journals, in the journal papers. So after seeing the conclusion, I'll tell you what happened to the report submitted to the government. So here you can see this construction of this weir will minimize the entry of seawater into the river system. Obviously, it will minimize the entry of seawater system because the temporary earthen bunds are frequently washed away by the running water. So this will be a kind of permanent solution. It will minimize the entry of seawater into the river channels. And the construction of the weir will improve the groundwater head because some quantity of water will be stored in the upstream side of the weir, that is known as ponding. So because of that, so groundwater recharge will take place and it will improve the groundwater head. So this will minimize the seawater intrusion in the aquifer system. And in future, we can divert the water. We can divert the river water to the salt affected areas through canals. So we can construct 2 canals. So in the either side of the weir, we can create canals and we can divert the excess water because it's a perennial river, and also during flood season, this river is carrying huge quantity of water. So we can divert the fresh water or the river water to the salt affected areas to go for reclamation of the contaminated sites. Then another important thing is we have to educate the people. They should not supposed to use the groundwater for producing salt. So because of this, more seawater intrusion is taking place in the subsurface, in the aquifer system. So this should be minimized or this should be stopped. So otherwise we cannot minimize the entry of seawater intrusion in the aquifer system. Then another thing is salt pan activities. So if you don't minimize or stop the salt pan activities, then we cannot get the proper remedy for this. So these are all the recommendations we are submitting to the government. So I told you our report is submitted to the government, and finally the government has accepted our proposal and they started constructing the weir. So now recently they have started constructing the weir. So based on our report, now you can see the field scenario. So they are constructing the weir. So already started constructing the weir in the coastal Tamarabarni area by considering our report. Of course, so with the help of their engineers, government engineers, so they have done the calculation. So they have done the calculation. Of course, you can see a clear match. So here, so we proposed one site, and of course they have taken the site very close to our site. So in our site, so the width of the river channel was less, minimum 380 meters. So here the length of the weir is 460 meters. So we have taken the narrow path of the river. So to reduce the construction cost, we have done like that. And they have, I will tell you the reason why they have chosen this site. And as per their calculation, so the height of the weir is 2.5 meter with respect to MSL, crest level of the weir. So based on our calculation, it is 2.2 because they decided to construct 1.3 meter height weir. So we proposed for 1 meter height surplus weir. Then the maximum flood level is about 5.9, and as per our calculation, it is about 6 meters. And we assume the maximum discharge as 2000, but they have assumed almost double. I don't know how they have got this figure. And as per the highways department, they got 1500, but they have assumed very high discharge. So maybe for the stability purpose, they have assumed high discharge. And as per our suggestion, they have also decided to go for 2 cutoff walls or sheet piles, one in the upstream side, another one in the downstream side. So this is our. So we propose 6 meter cutoff wall in the downstream side, and they have decided to go for 7 meters. And we propose 2.5 meter depth cutoff wall in the upstream side. They have gone for 2.6 meters. So almost matching. And here you can see. So this is the site we proposed for the construction of the weir, and of course they have taken this site. So because the people living in this area, they submitted request to the government. So if you put the weir here at this place, our village will be benefited. So like that, they have given their request to the government. So by considering their request, so they decided to construct the weir here, just few meters away. So here the width of the river is more. So you can see here, it is about 460. Obviously the cost will be increasing, but in our site, so it is about this narrow river channel at this area. So it is about 380 meters. So finally, so the government is started constructing the weir to give permanent solution to this particular problem. Right, almost I have completed my talk, and in future we have to concentrate on the other aspects also. And after constructing the weir, we have to study the performance of the weir. So it is an important thing. So we have to study the performance of the weir, and we can go for mathematical modeling for seawater intrusion. So using some software, ModFlow we can use, or some special softwares like Sutra is available. So GMS is available. We have to do mathematical modeling, and we are planning to use isotopes. So we have to go for isotopic studies to understand the present day seawater intrusion and also the paleo seawater intrusion. So we need to go for isotopic studies. Then, so is it possible to suggest some more weirs in the distributaries of Tamarabarni River to further reduce the mixing of seawater with the freshwater system? Is another big question. Then another important thing is it possible to go for subsurface weir, subsurface barrier, or subsurface dike to minimize the seawater intrusion in this area? Because it's a sandy bed, so seawater is easily entering into the aquifer system. Is it possible to go for subsurface barrier? Okay, so in future, so we are planning to work on these areas. So with this, I have completed my presentation, my talk. So once again, I thank the organizers for giving me this opportunity. Now this is, I leave this platform to the organizers for raising the doubts and questions.
Thanks. Ahora iniciamos la sesión de preguntas y respuestas. Now we start the question and answer session.
Yeah.
Por favor, doctor Jonathan, le cedo la palabra para iniciar con
Thank you very much, Dr. Subramani, for your nice presentations.
Thank you.
Uh, and it is really a lot of engineering work which you have done. And it is really good that you have done a lot of work on the South Indian side.
Yeah.
Muy buena presentación. Sí, es un estudio muy largo, muy amplio en el sur de India sobre la intrusión de agua del mar en, en un estuario. Eh, Primero quiero hacer una interacción con profesor Subramani, que tiene muy amplio experiencia en este aspecto. Entonces se la voy a hacer voy a preguntar sobre una comparación sobre la costa de mexicanos que en zona Pacífico compara con la costa de sur de India. Dr. Subramani,
Yeah.
how can you or can you give your opinion about the Mexican coast, especially in the Pacific side? And you have been in Mexico 2 or 3 times, I think. So if you see the Pacific side, you have a
Yes.
rocky coast. What do
Yes.
you think about the rocky coast? Will the aquifers get disturbed in the same way, or it is in opposite side?
Okay. So actually, one interesting thing is, so I submitted one proposal to carry out a similar study in Mexico also. So in India, we identified the funding agency as DST, and similarly, CONACYT is there in Mexico. So we submitted joint proposals and we got approval. And unfortunately, due to some reasons, we were not able to conduct that joint study. So actually, if the aquifer is different, then obviously, so the seawater intrusion status will also be different. So if the area aquifer is hard rock, then the scenario will be different. And we have to concentrate on the thickness of weathered zone. So normally the thickness of weathered zone will act as a kind of unconfined aquifer. And below the weathered zone, we can find cracks and joints in the rocks, and that can act as a kind of semi-confined or sometimes confined aquifer. So generally, in unconfined aquifer, we will face a lot of problems. So it will vary. Similar kind of scenario we cannot expect in the hard rock aquifers, and we have to concentrate on the intensity of the weathering, and also the secondary porosity present in the rock should be considered. So then only we can give proper remedial solution. So it will differ.
Yeah, it's
Yeah.
a nice reply. Uh, Doctor Subramani tuvo un
Yeah.
proyecto con India y México un año antes. Todavía no están los fondos suficientes para hacer este tipo de estudios. Es sobre los acuíferos, sí es un poco diferente comparar con agua y los arenas, y aparte aquí en México encontramos muchas rocas en zonas pacíficos. Pero aquí la más importante es la zona de interperismo, el tamaño de rocas, o puede decir la longitud o profundidad de las rocas, y el interperismo, la fractura de rocas, que puede ayudar en algún momento y también puede variar en partes. Y aparte, la más estudios necesita en ese tipo de zonas de interperismo o zona de rocas, es la más es interperismo, y aparte la porosidad también va a tener un papel muy importante para intrusión del agua del mar. Ese es en relación de una comparación con los arenas cerca de la costa, y aquí en México, en la zona Pacífico, es muchos rocas. We would like to ask a second question
Yes.
regarding restoration time of aquifers.
Yes.
What is your opinion? How long it will take in restoration, or
Yes.
sometimes the floods or hurricanes are coming. It's
Yes.
equal, it's the same in Mexico as well as it's same in India because it's on the same tropical zone. How
Yes.
far it will help us? I will just translate in Spanish so that
Yeah.
una interacción es, estamos preguntando la restauración de acuíferos en rocas, rocas aquí en la zona Pacífico y aparte en la arena, cómo va a variar. Y también estamos preguntando los huracanes o tormentas si va a ayudar para recargar ese tipo de acuíferos. Vamos a escuchar su opinión. You tell your opinion, doctor.
Yes. So not like Mexico, in particularly in this part of the study area, we are not frequently facing tsunamis. So in Pacific Ocean, tsunami is very frequent because your area is coming under ring of fire. So circum-Pacific belt. So the tsunami is very common, but here it is very rare. So 2004 December we faced one tsunami. So obviously the tsunami will create a lot of impact on the seawater intrusion. So more amount of seawater will enter into the river channel as well as into the aquifer system also. So we cannot predict this event. And of course, if we expect cyclone, it will give a positive impact on the groundwater and surface water system. If there is any cyclone or hurricane, so lot of fresh water will be flooded or inundated. So it will be a positive signature. But to restore the aquifer system, it depends on the so many things. So we cannot expect the tsunami or we cannot expect our hurricane to restore the system. So that is why we have proposed this kind of engineering solution. So if you implement this kind of system here, and if the people living in this area is cooperating, for example, they should not go for salt pan activities, and they should not extract more amount of groundwater for salt pan activities, then obviously, so quickly we can recover in few years. So it may take maybe 5 years or even 6 years, we can get a better result. Definitely it will give positive impact.
Thank you very much for the reply.
Yes.
Maybe I'll give this in Spanish.
Okay.
Tsunami es muy común aquí en Pacífico. A veces sí llegan algunos grandes, algunos pequeños tsunamis, pero en algún momento ese tipo de tsunamis que están afectando aquí en la costa de Pacífico a veces puede cambiar el nivel de acuíferos en la costa. Y aparte también los ciclones o huracanes que siempre llegan por la costa de Pacífico o en India también está en región, en misma zona de tropical. Entonces ese tipo de ciclones o huracanes también es una ventaja, sí es positivo, pero nosotros no puede esperar que llegue hasta la tsunami o un huracán para que cambie el nivel de agua subterránea. Por eso estamos buscando o esto puede dar una solución como parte de ingeniería. Y en ese sentido, la educación ambiental cerca de esta zona y aparte para una educación sobre uso de agua subterránea en esta zona es muy importante para que recuperamos la agua subterránea más rápido en lugar de esperar por tsunamis o un huracán o una tormenta más largo, y puede dar una solución ingeniería, puede recuperar en 4 o 5 años o máximo 6 años. Entonces es unas opciones. Thank you very much. I think, Dr. Juan, if you have some questions in YouTube, you can ask.
Gracias, Jonathan. Voy a hacer la siguiente pregunta del doctor Pedro, del CIIEMAD. Primero, muchas gracias por su actual e interesante conferencia. Desde su punto de vista, ¿qué papel juega una visión hidrogeoquímica para la interpretación de los fenómenos de interacción con el agua de mar en las costas y en la explotación de acuíferos.
What is the important point or important aspect of seawater as well as the freshwater in intrusion aspect? This is a question from Dr. Pedro Francisco Rodriguez. He's from IPN, CIIEMAD IPN.
Yeah, yeah. So actually, in the case of seawater intrusion studies, so we will identify the interface between the seawater and the freshwater system. So if you recharge the aquifer by means of artificial ways, so it will push the interface towards sea. So otherwise, if the groundwater head is lowered much, what will happen? This seawater, this dynamics balance will not be there. So seawater will enter into the aquifer system. It will push the line or the interface towards land. So this is the mechanism that is happening in normally in this area. And one more important thing is the upconing. So upconing will take place if you extract more amount of groundwater from the aquifers, and slowly it will reach the even shallow wells or open wells, and the wells cannot be used for drinking purpose. So this is the problem. It is happening in the coastal areas, and of course it is studied by most of the scientists, and even in this area lot of works research carried out already. So that is why we didn't concentrate much on the data collection and publishing the work. So we concentrated on giving solution to the people. So we decided to give this kind of solution to this particular area, this area specific. And of course, so we are fortunate and we are happy that so finally the government has accepted our proposal and started implementing this work.
Thank you very much, Dr. Subramani. La respuesta es la interfase de agua del mar o agua salada y agua fresca es muy importante porque hay una interfase donde puede interrumpir cuando hacemos una recarga artificial. Y esta interfase o esta línea de interfase es muy importante en cualquier ese tipo de proceso. Entonces, en lugar de hacer una recarga artificial, hay que estar muy despacio para que pueda recargar el acuífero completo o parcial también. Hay otro proceso en inglés se llama upconing o la curva que parecen arriba. Esa curva también es muy importante porque en algunas veces cuando hacemos una descarga o sacamos la agua más, a veces este cono también puede romper y en lo último, en el proceso, a veces el pozo también no puede utilizar. Por eso estamos dando una solución ambiental o ingeniería con base de área. No puede dar una solución completo completo, pero depende de cada área. Entonces hay que analizar, hay que dar con base de un área. Gracias. Thank you.
Okay. Siguiente pregunta, doctor Subramani.
Yeah.
Por otro lado, observo perdón, es también del doctor Pedro, de aquí del CIIEMAD. Por otro lado, observo con mucho gusto que utilizas, como nosotros, diferentes metodologías de las ciencias de la Tierra, como geofísica y geoquímica e hidrogeoquímica, para la interpretación y discusión de tus resultados. También lo hacemos aquí. ¿Podrías comentar algunas de las ventajas de este enfoque geoambiental?
Dr. Subramani, the
Yeah.
question is, we are using many techniques, for example, geophysics or the sounding method, or you are using geochemical aspects. And in particular, they are very specific and they want to know how an environmental related studies, especially in the aquifer, and what is your opinion and which one will be beneficial for the interpreting very easily.
Yeah. So each and every method is having its own, say, positive sides and negative sides. So for example, some chemical signatures. So that is why in my title, I have put the integrated approach. So sometimes, so we will not get the actual picture of the field condition. So that is why we are going for integrated approach. So we are using geochemistry as a proxy, and we are using geophysics, and we are also going for modeling. So in my opinion, so even based on the geochemical studies, so we can identify the seawater intruded areas. So, but the problem is, in many places, we will not find wells. So this is the problem. In many areas, you cannot find more wells. Even open wells may be there in some places. Only few tube wells or bore wells will be there. So in that case, so how will you go for geochemical proxy? So you will not collect more well samples. You cannot collect more groundwater samples. So you cannot depend on geochemistry in the case of limited number of wells available in the field. Then geophysics you can conduct. You can go for vertical electrical sounding. Again, the problem is the deltaic area and the field conditions should be suitable. So then only you can conduct vertical electrical sounding. But of course, you can identify the places and you can go for electrical resistivity survey. And of course, it's the cheapest method. So very easily, based on the conductivity and resistivity, you can identify the seawater intrusion intruded areas. And finally, if you want to exactly predict, when you go for prediction, we must go for mathematical modeling. So mathematical, I can say the mathematical modeling is the final technique by using the geochemical data, by using the aquifer parameters, permeability, porosity, and abstraction or the groundwater extraction rate, everything we can include in the model. And so finally we can predict. So what will happen after 5 years? So what will happen after 10 years? What will happen after 15 years? Then the modeling study will be finally useful to give proper remedial solution to the issue.
Thank you,
Yes.
doctor. La respuesta es cada método o cada análisis ya tiene su ventaja y desventaja. Por eso en mi conferencia ya le puse el título como una visión o un estudio sobre integrado. Integrado es proxies sobre geoquímica que puede hacer. Y también geoquímica es una herramienta o es un tema que es muy bueno puede hacer. Pero aquí el problema es a veces en algunos lugares no va a encontrar los pozos y entonces no puede tener suficiente muestras para tener unos resultados muy aptos para interpretar sobre geoquímica. Y en ese sentido quiero hacer la análisis geofísica o las sondas de geofísica es mejor. También aquí hay que tener una condición bien por el trabajo de campo y aparte es una metodología más apto, más barato que puede tener resultados más correctos. Y por último, quiero comentar es el modelaje matemático. Ese es un aspecto muy bueno que puede predecir cuando tenemos los datos de geofísica, geoquímica, puede incluir en ese modelaje y puede predecir por unos 5 años o un poquito más también sobre los acuíferos. Entonces, esos son unas metodologías más nuevos que está utilizando por el momento. Thank you very much.
Gracias, gracias, doctor. Vamos con la siguiente pregunta del doctor Luis Astudillo Wong. Y es, ¿usted considera las tecnologías electroquímicas para reducir los niveles de sal?
There is a question from Dr. Luis Wong,
Yes.
and he's from IPN. Do you consider that the electrodes which you are using, or some other electrodes which we can use to reduce seawater intrusion? This is a different question. Can you use electrodes to avoid seawater intrusion?
No, it is actually, in my opinion, it is not possible. Of course, with the help of the electrodes, we can demarcate the areas which are affected by the seawater. And of course, we are using different methods. Venner method is there, Schlumberger method is there. These two methods are commonly used. So the configuration will be different. Electrode arrangement will be different. So nowadays, so the people are going for resistivity imaging. So this resistivity imaging systems are used in different parts of the world. So they are using so many electrodes and they are creating subsurface images. So 3D view of the subsurface image we can get. So because in the modern technology, so particularly when you talk about surveying, so everything is image based now. So previously people were concentrating on one point, and now people are concentrating on million points at a time. So it is called point clouding, point clouds. So similarly, our interpretations are image based. So in the case of resistivity survey also, so using number of electrodes, they are trying to get subsurface images. They are trying to get 3D images of the subsurface to know better about the seawater intrusion. But with the help of the electrodes, we cannot stop the seawater intrusion.
Thank you, Dr. Subramani. Con respecto de la respuesta, y puede demarcar las áreas, pero hasta el momento no puede quitar la intrusión del agua del mar en este tipo de problemas. Pero en los estudios hay dos tipos, Venner Method, hay otro de Schlumberger Method, y los dos puede utilizar en muy buenas opciones. Y aparte, ahorita la más avanzado es la método de resistivity con imágenes. Ahorita hay imágenes de 3D de subsuelos, o que puede tener unas imágenes muy claras, y aparte ese tipo de imágenes están utilizando por el momento muy amplio por la interpretación de los resultados. Y aparte ese tipo de imágenes están utilizando también para recargar los acuíferos. Pero en mi opinión, con los electrodos no puede cambiar la intrusión por el momento. Gracias. Thank you.
Thank you.
Gracias. Bueno, pues vamos al cierre de esta excelente conferencia. Le damos las gracias a nuestro invitado por su estupenda conferencia. We thank our guests for his wonderful conference, Dr. Subramani.
Thank you. Thank you very much.
Ok, y bueno, por supuesto, os agradecemos mucho a quienes nos siguieron por YouTube. Los invitamos a la siguiente actividad de la Cátedra Patrimonial con la conferencia La teoría política granmasiana y la ciudad capitalista, con el doctor Jorge Octavio Gantiva Silva, de la Universidad de Tolima, Colombia, la cual se va a llevar a cabo el 12 de noviembre de este año a las 10 de la mañana, hora del centro de México, por este mismo canal. No se la pierdan. Gracias a todo este equipo técnico encargado de esta transmisión, Héctor, Jaime y Noé. Cuídense mucho y les vuelvo a recordar, pueden seguirnos en nuestras redes sociales. Y un comentario extra que lo debemos de tomar mucho en cuenta, quédense en casa. Gracias.